So let's go. All right, now I do want to say something. There was a question, for whatever reason, I think I was looking at the book and they left out this year a section. All right, I think there was a mistake because they have like graphing parabolas, and that was a section in the geometry books, which is actually an Algebra 2 topic. And I think for whatever reason, they swapped two lessons out. All right, so there's one that was actually in the unit from last year that's not in this year, and that's that particular section. So I'll show you it. It's very simple. All right, but anything on, and we have lots to get through, so we got to go. All right, is there anything on the first page that you want to talk about? Specifically, I would probably like to address number 8 to make sure everybody's okay with that. All right, and then we'll go towards the end, I think. But still, here, some of you came to my desk and I showed you this yesterday. The question is, OF is a what? Radius. So what you had to see was that DE bisects OF. So that means, if I blow this thing up, that means from here to here is half of a radius. Does everybody agree with that? Right, so that is a half of a radius. And then I always tell you that if you're not sure about something, draw from the center of the circle to a point, and that gives you the what? That gives you the radius. All right, and then DE is 12, so that means that this would have to be 6. All right, is everybody okay with that? Now it's just the Pythagorean Theorem, of course, so we would have 1/2 r squared plus 6 squared equals r squared. And again, what's 1/2 squared? 1/4 r squared plus 36 equals r squared. Now keep in mind, that's 1r squared. So 1r squared minus 1/4 r squared is what? 3/4 r squared. Is that okay with that? And then multiplying by the reciprocal, we end up with r squared is equal to 48. Then you take the square root of both sides, obviously. And the square root of 48 breaks down to 16 times 3. So r is equal to 4 radical 3. Everybody good now? All right, that's a good problem. All right, that's tricky, very tricky. Anybody else? Yeah. 1 minus 1/4 is what? See what I'm saying? All right, yeah.
Wouldn't that also be a 36 to 90 triangle since it's half of r over r?
No, that's a good question. I don't, so if that, oh yeah, because you could just take, because this is the 60, this is the 30, right? You can, you know, I think you're, because this is perpendicular, yeah, but for whatever reason, if I take 6 and, what are we looking for? Oh yeah, that does work. That's really good. I didn't see that. That's a really good job, right? Because it's half of the hypotenuse, then you can just divide that by radical 3. Very, very good. And that will be 2 radical 3. And then this would be double that. Wow, that was really, really good if you do it that way. I like that. Yes.
When you said that the 6 equals 3 over
There's 1r squared, and we're minusing, or we're subtracting 1/4. 1 minus 1/4 is 3/4. All right. Now, what was the other one someone was asking me about this morning? All right, I want everybody to look at 17. Unless there's something earlier than 17. Yes. Let's look at 10. All right, so EFGH is a quadrilateral. So you have to remember that the opposite angles of an inscribed quadrilateral are supplementary. You with me on this, right? All right, so these are little technical things that you gotta be able to do tomorrow. So you with me now, right? So you just have to draw it out, and then E and G are opposite each other, correct? And F and H are across from each other. Good. All right, so now let's take a look at 17. I want to show you this because it's just not that hard. Here, the section that was left out of the book for some crazy reason, and I should have known, but I just, for whatever reason, just didn't see it. All right, so please watch. All right, these are two secants. All right, this is two secants. So I want you to listen to me. It's not hard. All right, the rule is this: the outside of the secant times the entire secant. All right, and what's that entire secant? We don't know, right? So that's x. So it would be x plus 2 is equal to the same thing. The outside, which is what? 4 times the whole length, which is what? 9. All right, that's just kind of an additional rule. All right, there's one whole section that was left out of the book. All right, I don't know why. All right, I just honestly think it was a mistake. All right, so now if we solve that, x plus 2, I'm not going to distribute. Then I'm going to divide by 2. So x is equal to 16. Yeah. Oh, sure. Yes.
For this one, I got 16. Oh, yeah, 16.
Yes. Did you do it a different way though?
Yeah, I just kind of used used my reasoning, like I added 4 and 5, and then.
Yep, that's what you're supposed. And again, you may have looked up. There is, like I said, if you didn't know, you could have looked this formula up. All right. All right, but again, remember the rule is the outside part times the whole length is equal to the outside part times the whole length. All right. Isabel, what did you say?
13.
Let's take a look at 13 now real quick. All right, circle A has its center at 3, 2. All right, so here we go. We're going to just draw a circle. This point right here is 3, 2. And CB is tangent at 6, 4. So I'm going to put this point right there is 6, 4. And then we're going to draw a tangent line. So what's the slope of CB? Well, remember what I told you. Draw from here to here. So what's true about those two lines? They are what? They're perpendicular. So I need the slope of this, and that will tell me the slope of this. Isabel, do you know this? Do you know that this is perpendicular here? Right? So all I have to do is find the slope, right? So you remember to find the slope. So m equals 4 minus 2 over 6 minus 3, which is 2/3. Do you agree with that? So then the slope of the perpendicular would be Yes. Negative 3 over 2. Negative or simple. Everybody okay with that now? Everybody okay? All right, moving forward. I actually, what? All right, let's look at 24. The radius of circle C is 16. Find the length of the arc that has a measure of, 270 degrees. That should be degrees. You with me? Which just means it's what? What's 270 degrees? 3/4 of the 3/4 of the circumference. Just like the one earlier, it was 90 degrees, if I'm not mistaken. So 90 degrees represents what? 1/4 of the circle. If it said 100 degrees, it would just be 100 out of what? 360, right? That's the formula. The arc length is the circumference times n over 360. All right, so in this case, it is 3/4 the circumference. Do you agree with that or not? So if I do 3/4 the circumference, it's going to be 3/4 times 2 times pi times 16. That's 4, 6, 24 pi units. You agree with that? All right. Arc is 2 pi r times n over 360. Yes. Well, I did 16 times 2 times 3/4. Right? 16 divided by 4 is 4. 4 times 3 times 2. Agreed? Right? Somebody else now. All right, I really want to get to the end problems because those are important. Yes.
22.
John wants to put a circular decorative glass in a table. He cuts a hole in the table that's 20 inches in diameter. He used a thin metal frame along the edge of the hole. What is the length of the frame? Well, the frame is circular, correct? You agree with that?
Yes.
And it just says it has a 20-inch diameter. So that's just a circumference problem, correct? All right. Moving forward here. Yeah, I believe 29 was the same exact principle. You had trouble with 29, right? What? Yeah, 29 and 30 are from the same section in the book that we skipped. It's a what? And it is. You're right. How did you do the proportion? Yeah, I'm proud of you for that. That is correct. All right. We can also say this. You can also say that the way it's taught in the book is this, guys. Please watch because, you know, I kind of want you to know this, and it's my fault partly, but I don't think it's hard. All right. So you are 100% correct. I was happy with that. The way they describe it in the book, though, is they just say the parts of the chord are always, when you multiply them, are always equal. So please watch, you guys. So this would be 4 times x plus 1 is equal to 3 times x plus 5. All right, so this part times this part is equal to this part times this part. But man, that's really good near proportion. All right, that's exactly correct. All right, now with my explanation, what? That's what we're doing right now. All right, I explained this earlier now. All right, that was the same as number, which one, Dalton? It's the same as 17. It's the same as 17. These are two secants. All right, so watch again. The outside, which is what? X times the whole length, which is what? Someone? X plus 1 is equal to the outside, which is what? 4 times the whole length, which is, you guys agree with me that that's not that hard. I would know this for the test. All right, but probably, honestly, I probably made the test. I might make an extra credit question. You with me on that? I might do that. All right, I think that's fair. It's my fault. All right, I should have recognized it, and I just didn't. All right, but does everybody see that's not that hard, right? Outside times the whole length is equal to the outside times the whole length. You with me? So in this case, this would be what? X squared plus X is equal to 56. Bless you. Now we have a problem. X squared plus X minus 56 equals 0. Factoring X plus 8 times X minus 7 equals 0. Can X be negative? No. It's called an extraneous solution. So X was 7. So X was 7. All right, and again, that's just a really great review question. Some of you guys taking the entrance exams coming up. You're going to have to factor. You're going to have to set factors equal to 0. Please look up. Make sure you see that. Any issues? Any issues? All right. Here we go. The 31 through 34 is pretty interesting just because it's a weird looking figure, right? What? So you had trouble with X, U, Z. Let me see if I can find X, U, Z. Right? Now, my question to you is that right there, that angle, see if you agree with me, is the average of this right here and this right here. Do you agree with that? Well, that's a rule, right? That's a rule. Yeah, we definitely learned that. So again, for those of you guys who may be a little unsure about that, anytime you make, right, an X on the inside, this angle is the average of the intercepted arcs. All right, that's a rule. All right, like I said, you just gonna have to review the rules. I'd go through all the worksheets and just look at the rules over and over. Everybody just remembers that, right? All right, that's just a rule. So I need to find what YW is, or I need to find what ZW is. All right. Do they give us anything? Say it again. Come on. Good for you. Yeah, that's what I'm asking you. All right. So, first of all, to me, it's easier just to try to get as many angles as I can. Does everybody agree with that? So, remember now, this angle right here has to be 70 degrees. Do you agree with that? Because that's half of 140. Now, the other thing I think that is really sneaky is, listen to me, guys. Please listen, because I almost didn't see it at first. If a diameter is given, we know it's 180 degrees, correct? Come on now. So that solves the whole problem, right? I didn't recognize that XW right off the bat was a diameter. Does everybody agree? So that means this WZ right there has to be how many? 40 degrees, correct? Everybody? Now, someone else tell me what YW has to be. 80. You happy with that, guys? Now, do you see how you can easily overlook that? True? Does everybody see that? Because I almost overlooked that. I'm telling you guys, it's like drawing a radius. If you get in trouble, draw the radius. What?
So angle XYW equals 70 divided by 2.
140 divided by 2. That's an inscribed angle. It's half the arc.
Yeah, but X, U, Z, you didn't divide by 2.
X, U, because it's not an inscribed angle. Inscribed angle, remember the vertex is on the circle.
Oh, okay, sorry.
Right? You agree?
Yeah.
Miss Alonzo, you good now?
Yeah.
So now this angle here is the average of 140 plus 80. So that would be 110. XUZ would be 110 degrees. Come on now. This is a great review question right there, guys. Very good. I need you to speak up. What? I looked at the figure. But if you don't know how I got 80, I can explain that because that's what we just did. Look. Didn't I say this right here is a diameter, right? All right, now again, I'm not being funny now because again, I think it's important. I almost missed it is what I'm trying to tell you when I was first doing this. So now, how much is from X to Y? So that means from Y to W, that has to be what? You're right, 80, because it's a semicircle. Yes, that's what we're saying. Look, and I'm just telling you, if you're not with me, all right, you can make it's so obvious if you just see it. Right? That's why I'm saying on the test tomorrow, I'm trying to give you some hints. Draw the diameter. That shows 180 degrees. Then it kind of clears things up if you're not careful. So 31. Now I'm looking at PQR. So I'm finding PQR, this angle right here. Now, that is on the exterior, so that is the difference of the arcs divided by 2. All right, so what does that mean? Right here, I'm looking, let me make this better. Okay, please watch, everybody. So, this angle, or this arc here, is how much? 240 minus this arc right here. 240 minus 120 is 120. Now we divide that by 2. 60. You hearing me on that now? All right, go. Come on.
Couldn't you just also add 80 plus 40?
No, because that again is not an inscribed angle. The only one that you divide by is this. This would be, is what I'm trying to make sure you're understanding me. That's an inscribed angle. That vertex is on the circle. It's just a coincidence. All right, just a coincidence. That's true. All right, guys, come on, come on. I'm feeling a little better about it. All right, anybody else on 31, 32, 33, 34? What? So P, Y, X. All right, so again, that is another rule. That vertex is on the circle, so it's half of the arc. The vertex is on the circle, so it's half the arc. That arc is what? 100 degrees. Therefore, the angle is what? 50. All right, we got to get going. What? All right, we're getting going. All right, okay, this is one of my favorites right here, guys. All right, this is a great, great, great algebra problem. And I'm just going to tell you it's on the test. All right, it's on the test. I'm expecting you to know how to do it. All right. Now, again, this would be classified as a system of equations. So please watch. Once I set it up for you, it'll be easy. All right. Now, normally, this would be hard, but because we're brilliant, it's not. I have to eliminate a variable, correct? The easiest variable to eliminate is the y squared. You agree? Right, now what am I going to do? I'm just going to distribute a negative here. Come on, distributing a negative. Now when I add them, what happens to the y squareds? They cancel out. Come on, guys. So I end up with x minus 2 squared minus x plus 3 squared equals 5. I don't think that's hard. Look at that. Everybody good with that math? Now I just have to expand, correct? What? Come on, not half up, half down.
How did you distribute
What do you mean, how did I distribute?
no, why did
Because I'm trying to eliminate y squared. When I add y squared and negative y squared, what happens now? And now I just have x's, and there's no y's. It's the elimination method of the system of equations. You're trying to eliminate a variable. Now we've done that. All right, now I am hoping everyone in here, you'll freak your math teacher out next year if you can square x minus 2 squared. What is x minus 2 squared? Right, it's just a pattern. All right, x squared. The middle term is always x times negative 2 times 2. Now, we're distributing the negative here. So the first thing I'm going to do is put minus, and then I'm going to square x plus 3 squared. I want to hear it. Go. That's pathetic. X squared. What? X squared plus 6x. Wow, you are not going to impress anybody next year with that. Does everybody see what I'm getting at, though? Come on, if you don't, raise your hand. All right, you square the first term, multiply x times 3 times 2. That's the pattern.
Why is
Because now I have to distribute the negative.
Oh.
All right, so now watch how much easier it is. X squared minus 4x plus 4 minus x squared minus 6x minus 9 equals 5. So that's nice because the x squareds do what to each other? So now I have negative 10x minus 5 equals 5. Negative 10x equals 10. So x was what? So x was what? So x was negative 1. All right? Did we just find out x was negative 1? So now I plug negative 1 into the equation. Is everybody with me? So if I plug negative 1 in for x, what's negative 1 plus 3? Squared. So now I have 4 plus y squared equals 8. Y squared equals what? Now, you have to be careful. Here's where everybody makes a mistake. Y is equal to what, guys? I knew you were going to say that. What does y equals, guys? Square root of 4, brilliant. Square root of 4 is 2, but what are you forgetting? So the answer is no. Say it again. Yeah, everyone forgets that, so don't forget it. Plus or minus 2. Because what's negative 2 squared? What's positive 2 squared? So there are two solutions. Anytime you take the square root of a square, it's plus or minus. You agree with that? So if I said x squared equals 9, you could tell me x equals plus or minus 3.
Is this one going to be like a regular or?
This is This is just algebra, man. You got entrance exams coming up. You got to be able to do this. So the answer is negative 1, 2, and also what? Negative 1, negative 2. If you were to graph those two circles, they would intersect at negative 1, 2, and negative 1, negative 2. That's all that means. Again, listen to me. Review that, please. All right. Now, the SAT and ACT questions. Brilliant problems. What do we need, guys? Come on. I don't think those were that hard. Do you agree? Anybody want me to do one? Go. 40. Let me see if I can do 40. Okay, now this one I think would be a great problem because the shaded region is just the area of the big circle minus the area of the small circle. Do you agree with that? You okay? So its area equals pi capital R squared minus pi lowercase r squared. And I just gave this to my pre-algebra class. All right, that was on their test. What's the big radius? 10. Area equals 100 pi. What's the radius of the small circle? 5. Minus 25 pi, 75 pi. That's a really nice question. Are we okay with that? All right, guys, I'm having fun. What else? Say it again. Let's try 41. Okay, this one's a really nice looking problem. So it says in the figure below, the circles centered at P and Q intersect at A and B. All those points are collinear. The length of PB is 9, QB is 12, X and Y. So everything is 2. What is the length of PQ? What is the length of PQ? So someone tell me quickly, what is QY? What's QY? Who said that? How did you know that? Right, now remember, I'm telling you guys, listen, here's how I'm going to make you good with the geometry. I told you already that this is the what? What's that called? Radius. I'm telling you, that's a secret to these problems. So what is from here to here? That's also a what? Yeah, if you learn to do that, all of the problems now are simple. So tell me what YQ is again? 10. See how sneaky that is, right? But it's not that hard if you do what I'm asking you to do. When you get in trouble, look at the radii. All the radii are equal. That was good, dog. All right, so now tell me about PX. Yeah, now look how easy. All right. So it has to be, I'm thinking 19, right? Because we forgot to add that 2 in, right? That's good. All right, very good. All right, someone else now. Come on. Come on, guys. We got 10 minutes, 8 minutes. I was in a hurry. Nothing? 46. Oh, yeah. Now, this one's a really, really nice problem. All right, so it's a regular what? Hexagon. So what can you tell me about angle A, B, C, D, E, and F? They're all equal. Do you agree with that? Now, what is the measure of CAD? That's what we're looking for, right? Everybody good with that? Hello? Right? Now, you guys, is that an inscribed angle? Is that an inscribed angle? Yeah, it is. So all I have to know is what CD is. That's all I have to know. And what's CD? I'm thinking it's 60, right? CD is 60 degrees. I'm just asking you a question. Isn't CD 60? Yeah, as usual. So what's the angle again now, Charlotte? This is your cue. Yay. 30 degrees. All right, not a big deal. That wasn't that hard. All right. Lots of ways to do that, actually. All right, somebody else. Someone else. That was a good question. All right, Emily. 43. All right, let's talk about this. Now, hey, everybody look up. Is this an inscribed angle? No. That is a central angle. That's a central angle. So in the circle above, point A is the center, and BC is 2/5 of the circumference. Do You agree with that? Therefore, angle X must be what? 2/5 of 360. Thank you. That was brilliant. 2/5 of 360. Which is obviously 144, right? Somebody else. We still got a few minutes. 5 minutes. Gavin, nothing out of you today. You're just ready to make 100, huh? Oh boy. Someone else, give me a plan. Yes, ma'am. Let's try 44. Uh-oh. The figure below, there's a square there, right? So what is this angle right here? And this is 90, 90. That's what I would do. All right. Now, these are all equal to, just to make sure. Not that that's necessary, but that's just what I'm doing if I'm trying to get these ACT questions. If the area is 36, that means the radius is what? What?
6.
What is it?
6.
6. That's what I thought you said. The radius is definitely 6. Do you agree with that? What's the area of a square? What's the area of this square? So the side length has to be, because 6 times 6, 36. You good now? All right, that's important. So everybody, you happy with that now? All right, so now we just have to answer the question, what is the area of the circle now? 36 pi, because the formula is pi r squared. All right, guys, man, these are great questions. All right, guess what? 45 was also on my pre-algebra test last week. If you missed that one, come join us. What's 45? That's a great question. What? The area of a square is 49 pi?
Okay.
D, what are you talking about? D.
I was thinking the last one, but then one.
That would be A, B, C, D,
Yes,
E.
I know, but
oh
I didn't
my
realize there were
gosh.
5 answers.
Harrison, looking good today. Yeah, really, that was good. Your only response today is incorrect. The correct answer, though, is what?
196.
196. Okay, that is correct. All right. Now, did everybody see that? Just because of the way they drew the what? The radius in. Right? If you would redraw the radius this way, you could clearly see the side would be 14. Very sneaky. All right, very sneaky. That's why I'm trying to tell you, draw the diameter, draw the radii. If you don't see something, draw in a bunch of radii and diameters until you see a better picture of what they're asking. Somebody else, we got 3 more minutes.
42.
Really? 42? Okay, so now this one's another really great question. Because you guys failed this miserably, what is this angle called right there?
Central.
Central angle. Yes, it is a central angle, which means it's how many degrees? 112. So what's true about angle A and angle B? They're equal. So whoever asked me that now, it's just 180 minus 112 divided by 2. Everybody happy with that? Yes, ma'am.
Sorry, but can you do 48?
Let's try 48 and don't be sorry. Here we go. 48. Oh, this one's a really nice problem too. All right, good little thinking question. So it says a fan has 5 identical blades that are equally spaced around the center of the fan as shown below. What is the angle, or what is the measure of the angle of rotation that would move blade M clockwise to N? They're evenly spaced. Do you agree? So that means each angle would be how many degrees? How much? 72 degrees. Right, okay.
360
Right. Does that make sense, though? Yes? So that's a very good question. So do you agree that each space is still the same, though? Right? So there's still 5 of those. You with me? So if I were to measure from here to here, that would still be 72. Somebody else. Alright guys, I'm pretty happy with that. Do I need to review with you writing that in standard form? Half and square the middle term, right? So again, just to review, x minus h squared plus y minus k squared equals r squared. Do you agree with that? Okay, number 50, what do I have to do first? Divide everything through by what? You have to divide everything through by 2. Alright guys, if you have any questions, see me in the morning. Alright, if you have any questions, see me in the morning. Good job, good job, good job.